So I am going to introduce our next speaker. And I'm really happy that he's here, actually, because this is a big coup for me. I'd like to introduce Addison Snell. He's the veteran of the high-performance computing industry and the co-founder and CEO of Intersect 360 Research, now in its 15th year, delivering forecasts and insights for high-performance markets. He also happens to be a crossword puzzle creator and actually got his crossword puzzles in the New York Times Sunday supplement, yeah? And as well as the Wall Street Journal, too. So he's not a flash-in-the-pan crossword puzzle dude, but I thought that was pretty cool. Oh, he wants my lab, doesn't he?
Put it in my belt. Thank you very much, Jay. I'm thrilled to be here. My name's Addison Snell. I'm with Intersect 360 Research. I haven't presented at a SNIA conference in a long time, so I'm absolutely thrilled to be back. I'm going to give intentionally a pretty high-level talk because as an analyst, that's what I typically do. And the title of it is 5 Big Questions for HPC and AI in 2025. This is based on an editorial that I wrote earlier this year that was published in HPC Wire. Should be pretty easy to find if you go look for it. The reason I wrote it was because we were coming off of 2024. I'd been at the supercomputing conference. There was a new #1 system on the top 500 list. We're into exaflops. There was record attendance. The vendors are all booming. And yet, it kind of felt like there's this buzz of everything's really unstable. And that had everything to do with this dynamic around AI and what's being driven by the hyperscale community. There's a big election going on in the United States. We didn't know what was going to happen. And I found that as I looked at some of the big market factors that really affect us, that it feels like a lot of going on in the industry is really at a tipping point. And we outline this in different ways. And it certainly has implications for high-end storage and networking, which I'm going to focus on a little more here. We mentioned we're in this is our 19th year tracking HPC and AI. We've started a new organization, the HPC-AI Leadership Organization, which I'll spend a minute on. I have way too much content here, so I'm going to try to blast through it, and I'll be here throughout the day for questions. The team is growing. Many of you might know Steve Conway, who's been an analyst in this space a long time previously with IDC and Hyperion. Now on our side, I've got 2 other analysts who've joined the team. This HPC-AI Leadership Organization is a new global end-user organization for HPC and AI users that is helping to steer the direction of the industry by not just participating in, but steering our research and talking about what areas they would like to see more studies in. So I'll make reference to this throughout the presentation. There's a QR code there. If you're an end user who deploys HPC and AI, please do join. There's absolutely no cost to do so. If you're on the vendor side, you have products and solutions in this space, you can also apply to join. You'll be rejected. This is strictly an end user organization for right now. We will do other things with the vendor community, but that's not because we don't like vendors. It's just because the vendors come to us and say, well, what do end users think about this? And then we have to keep the vendors out of the survey that then does that. So that's why. It's not that we don't hate, we love the vendors. It's just that the surveys are for end users. All right, so I promised 5 big questions. The biggest of them right now that people ask about is how big can the AI market get? And it's kind of a tricky question because the first thing that I like to do as an analyst when we talk about a market, if we're going to talk about the AI market and someone's going to say, well, it's, however many billion dollars and growing at, 70% or whatever it is, how many AIs is that and how much does each one cost, right? That I feel like if we're going to do a market forecast, we at some point should have a pretty clear methodology document about what things we're counting specifically. Now, we're high performance data center analysts, right? So at some level, we're going to be talking about scalable clusters that are solving these HPC and AI workloads and not things like smartphones or self-driving cars. Are those part part of the AI market? I'm kind of, yeah. There's lots of things that are part of the AI market, but self-driving car is already part of the market for cars. And we're not counting those things when we as analysts count it. We're counting data center infrastructure. And in general, we've gone from talking about the HPC market to the broader HPC and AI market. This is a weird time of year for me to do this because we're about 2 weeks away from finalizing our 2024 numbers and doing a new forecast. But we did update them, and for most of 2024, we look at the supplier analysis. Those are NVIDIA's data center numbers there on the right. They've been going up mostly linearly for the last year and a half, which actually means from an exponential standpoint, it's slowing down a little bit. I do feel like this is groping for an asymptote somewhere. We also look at other major suppliers. Everybody is trending, not everybody, most are trending into the 75 to 150% growth rate year over year, including companies like HPE and Dell that we usually think of as bellwethers for the on-premises portion of the market, but each of them had major hyperscale sales also in 2024. Dell was one of the vendors on the Colossus supercomputer that went into xAI together with Supermicro. HPE also had a major hyperscale sale. So separating out hyperscale from the rest of the on-premises market is really one of the big things that we work on because when we compare that to what end users say they're doing, is there a pointer on this? Is this a pointer? There is a pointer here. These are different budget categories from no change to up a little bit more. This is up by more than 20%. And we can see that most of the end users are trending into this up high single digits or up low double digits, but nothing like doubling of budgets. There are very few on-premises HPC-AI users where we find, yeah, we're doubling our budget year over year because of AI. So where is this huge growth coming from? It's mostly coming from the hyperscale portion. So this is the on-premises, non-hyperscale HPC-AI infrastructure forecast. We did increase this mid-year to where we added a little bit into 2024. We added a lot more into 2025. We added $16.5 billion into this and increased the growth rate going forward. But that chart I just showed combined is this darker blue portion down here. This lighter blue portion is spending by hyperscale companies. So we're either talking about, most of it is the large multi-line hyperscale companies, your Google and Amazon and Microsoft and X/xAI/ whatever other companies kind of go together under that. These are companies that are spending tens of billions of dollars a year on AI infrastructure. Run that number back a second. We really have trouble as analysts emphasizing the difference in the level of investment between a hyperscale company and a large-scale supercomputer site. If I'm building a new top 500 supercomputer, I'm going to go like into the top 10 of the top 500 list. I'm probably going to spend $100 million or more on a supercomputer to go do that. And we've seen some of the top ones go into the multiple hundreds of millions of dollars. There are multiple hyperscale companies that are spending 100 times that annually on AI infrastructure, tens of billions of dollars a year. And this has a tremendous effect on the market because, we're going to hear from Gary later, and we're used to thinking of these DOE and other international labs as the market leaders that are pushing levels of scalability. And this is one of the different dynamics where that's just not the market driver right now. Now, HPC has always been at the wag end of a larger enterprise computing market. What's changed is what's doing the wagging. It used to be enterprise computing writ large, but now it's hyperscale AI is really driving the bulk of the investment going forward. It's taken off. Hyperscale AI is more than 6x in 2024 where it was in 2022. And we've been sizing this for a long time. The reason outside of hyperscale, the reason we talk about HPC and AI together is it's getting increasingly difficult to separate them. As much as we talk about enterprise AI, now this is last year's survey, we reached out to 264 total large enterprise. 95% had HPC or AI budgets. 5% had neither. What we found is that we found 10% had HPC and no AI. We found 10%, 11, who had AI only and no HPC. And the other 80% in the middle had both somewhere, right? It was large. So if I go to Oak Ridge National Labs, is that part of the HPC market? Of course. Is it not also part of the AI market? It kind of is. Something like the Tesla Dojo supercomputer we talk about as an AI supercomputer. Does Tesla not also do any computer-aided engineering, crash test analysis, aerodynamics? They kind of do, right? So they're at different places on a spectrum, but they're both part of this merged HPC AI market. And then we can look at, are the budgets together or separate? Are they mostly HPC, mostly AI? We have redone this survey for 2025. We've not released those numbers yet, but what really has happened is this HPC only portion, that's really what's going away. It's very rare now that you find someone who's going to be doing high performance computing who's not also doing AI as part of the same budget. They exist, but it's on the order of 1-2%. So it doesn't really make sense to talk about an HPC market in absence of AI. This AI only portion, not really growing. It's not, we don't see a lot of people doing on-premises AI where it's not mixed somewhere with HPC. There's some of it, but it's not huge. Where we find the AI only is in that hyperscale side. So when we look at the effect on storage and networking, there are differences. If you go to the on-premises HPC and AI, storage tends to be about 25% of the overall infrastructure budget. If you go into the hyperscale AI, it's more like 5%. The reason for that difference is mostly the cost of the GPUs. The hyperscale AI infrastructure are really GPU dense, and those GPUs are really expensive. If you go into the HPC and AI portion, it's not that they aren't they are buying GPUs, but you go from it's always 8 or more GPUs per node, and the CPUs are a little lighter or whatever. You get a lot more, 1, 2, 4 GPUs per node, and storage comes up. The other reason is if you're going into pure AI, a lot of it is data that you've already got. So you're not counting that legacy storage as part of the AI infrastructure cost. HPC and AI, you still have this tiered hybrid storage with flash, disk, and tape versus hyperscale AI is almost all flash. Now what we do see, and the parallel file systems are different too. We've been talking about parallel file systems in HPC for a long time. Often still none. If you go into the commercial side, there's still a big just use of NFS and selling redundant filer heads as I grow. We find that in the commercial spaces outside of oil and gas. Oil and gas has adopted a lot of parallel file system. Commercial HPC, other than that, the parallel file system adoption has still been low. I'm a big believer in parallel file systems. We just didn't see them. And we talk about tiering here more than anything else. Hyperscale AI, they don't talk about the parallel file system much. I think they're using them, but they're embedded as part of an overall data platform that come from a lot of these HPC storage specialists. This is where it does have in common, because we've seen companies, I always hate mentioning companies here because then I leave some out, but we've got HPC storage specialists like DDN or Panasys, which became Vidura, Weka, Vast, Hammerspace, and there's going to be more than that, right? I don't mean to leave anybody out. These companies, they split the market with your traditional enterprise storage people who are still over here in HPC and AI. Your NetApps and EMCs have huge market share in this space, but those companies have been left behind in the huge data boom in AI and hyperscale, where those HPC specialists I mentioned have really taken off with hyperscale sales. Now I mentioned networking. Here it's been about half InfiniBand, half Ethernet for years with different pulses depending on where you get a different speed bump year over year. Now NVIDIA networking has dominated this with the inside lane, but we really want to track what goes on with Ultra Ethernet Consortium as we start seeing new UEC compliant products coming into this space, because I think in the commercial space there really is a preference for Ethernet. We've seen that on the HPC side for a long time, and you kind of had to drag them into InfiniBand. Well, now I'm buying all these InfiniBand-based solutions that are embedded from NVIDIA. Would I rather have something that's Ethernet focused? Now NVIDIA is part of UEC, not one of the founding members, but even before the acquisition by NVIDIA, Mellanox was trending into what are some Ethernet related products that are coming out of Mellanox. So this could be a really interesting development that we see going forward. Finally, when we talk about the enterprise AI opportunity here, I tend to moderate this a little bit because, all right, yes, AI is coming, and it's going to be a remarkable, transformative effect in this space. Someone asked me at a conference 2 years ago, have I ever seen anything in my career as an analyst that had as much hype and promise to change the world as AI? And I had to think about it for a second, and I thought, well, yeah, one. The World Wide Web in the late 1990s had this much hype and promise to change the world. And it did, in some ways beyond what we expected, because in the late 90s we weren't thinking about smartphones and apps and things like that yet. That took time. But the path to investment was irregular. Now, when we talk about did companies overall become more profitable because of that? I think there was a new market dynamic. There were people who adopted it faster or slower. If you're going to be profitable, there are really two ways to do it. And check me on this, right? If I want profits, I can either increase money coming in or decrease money going out. Those are kind of the two main ways to do it. And with AI, most of the discussion has been on reducing cost. I'm going to optimize my workflows, or I'm going to, let's face it, reduce headcount, something like that. Well, there's a limit to that. First of all, there's a riddle. How much money will you spend to save $1 million? Even if you annualize it, how much money will you spend to save $1 million a year? It's kind of capped. It's not infinity. It's probably not even $10 million. And then it's hard to repeat the trick. Just because you've done it once doesn't mean you can do it again, right? So there's a limit to how much people will spend on that. And in terms of increasing revenue, this really gets you very quickly into a prisoner's dilemma, where are you really making the market bigger? Are people going to take more flights overall because the airlines have chatbots? Probably not. There might be an argument for I can fill the planes better, but at the base level, did people fly more because of AI? Probably not, right? Not very much. And you can look at this with web too, and Amazon, right? Did people read more books because Amazon existed? Maybe a little. I mean, that'd be a tough argument to say the market for books went up because how you sold them changed. So a lot of this becomes, stealing share and being more profitable. AI becomes the new cost of doing business really going forward. All right, so speeding up a little bit through the other questions, does hyperscale completely take over enterprise computing? Because cloud has been plateauing in terms of the overall proportion of the market of on-prem. And we even see this with LLMs, that people prefer them internally to externally for LLMs. But as hyperscale takes off, it can become effectively the only choice for sandboxing new technologies going forward. If hyperscale really dominates the supply chain for new technologies, you can get very quickly to where cloud becomes the only mechanism for adopting new technologies. This was a report we wrote a little more than 5 years ago now about the worldwide hyperscale size of the market. None of this will slow down in the next few years. Barring a significant change to the competitive sphere, tier one hyperscale companies will become even more powerful within the forecastable time frame. Such market power is not unprecedented in the world's history, but has not been previously seen at this level in the information technology era. I think this is, still true, and has everything to go going forward with this third question: what effect will the new U.S. administration have on the HPC and AI market? Now, it's not my role as a market analyst to say who anyone should vote for or who's better or worse, but it is my role as a market analyst to look at major geopolitical changes and think about how it affects the market. And some of our Halo organization, High Peak, are all highlighting HPC and AI nationalism issues as threats to progress. The idea that each country has to have its own infrastructure, and data and innovation or insights shouldn't be crossing national boundaries. The Stargate project was announced the very first week of Trump in office. This was the up to $500 billion infrastructure through OpenAI and a lot of other partner companies. Now, that was obviously already in the works before the election, so it's hard to say that Trump gets credit for the creation of the project. I mean, he'll claim it. It's hard to claim that he actually created the project. Does he get credit for creating a regulatory environment that keeps more of the infrastructure and jobs in the United States? Maybe. That's something that you can talk about. But this is the direction he wants it to go. On the other hand, anyone recognize this icon here, what that is? It's not Bitcoin. That's the logo for the Department of Government Efficiency, or DOGE, which is now going up against all of these things. And it creates a really weird market dynamic. As an analyst, I have to consider now that there's a live question within the 5-year forecast. Would Elon Musk advise Donald Trump that organizations like NOAA and NASA could be shut down in favor of private sector contracts to xAI and SpaceX? And if so, would that happen? That is a realistic question that we have to look at in our market forecasting right now. And that's not to say whether that would be better or worse, but just would it happen? Right? And, the conflict of interest things that go involved, or what's the purpose of the government. NSF, NIH are all under pressure right now. If you look at major academic supercomputers that are awaiting NSF funds, that are currently in limbo a little bit to complete the installations of these things, all of this is kind of creating this weird market dynamic right now. Question 4 becomes, can anyone challenge NVIDIA, which is, I already showed the chart of its growth going forward, and it's got a lock on the AI market right now. And this is, I can get into accelerators per node is going up. This is market share within the blended HPC-AI market. If you go into hyperscale AI, it's even bigger. There is some AMD and other things in here. AMD has been popular among the HPC set for price performance issues, but is still seen as being behind on software issues and others. When we get into the potential challengers, Intel and AMD are your conventional ones, but Intel has tried and failed to come out with competing accelerators on the GPU side. It still has some products with Gaudi, but nothing like what NVIDIA is doing. AMD is in there swinging away on the on-premises HPC AI deployments, but hasn't really dented NVIDIA's dominance on the hyperscale side yet. There are any number of startups here, and again, I can put a bunch on the slide, and I'm going to leave out dozens more. These are some of the noteworthy ones on the HPC side, Cerebras and Grok and Semino. But none of these are really big enough that they're going to crack what's gone on with NVIDIA so far. I think the most interesting thing is the new paradigm, because on the one hand, NVIDIA is now building up its own clouds, or clouds by proxy, your generations of GPU-focused AI clouds, CoreWeave and Lambda and things like this, which are now going to compete with these cloud companies who are NVIDIA's primary customers, but who also are designing their own processors to take NVIDIA to take out their reliance on NVIDIA. And I've never in my career as an analyst advocated the strategy of competing with your own customers. And yet here we are. This is the dynamic going forward. And I think the most interesting question is to roll this forward a little bit. I think the question isn't NVIDIA versus Intel and AMD going forward as much as it's NVIDIA versus Microsoft and Amazon and Google. xAI is an outlier here because they first of all just recently made the move to go into the tier 1 of hyperscale with getting into that tens of billions of dollars with Colossus last year. But they also are the ones that don't have their own processors in development much yet. It would be interesting to see whether xAI is going to acquire one of these other companies in order to get into the game, acquire an inference engine in order to then compete going forward. I think that's a predictable thing. Okay, and then last question, what about good old HPC? Because we're up here talking AI, and that's what's driving a lot of the investment. This really has a huge impact on the compute side, the processing side. I don't want to beat this to death because I'm up here talking about storage and interconnects, but the biggest effect is on precision because the HPC set really wants 64-bit, and that's what you're starting to lose going out of the market. Thank you for that. Programming languages, there's also a big effect because HPC has been, we've seen Fortran that's already diminishing. C and C++ are the dominant things, except all the kids these days, they're doing Python or something else, right? So Python has now become the dominant HPC language for new development going forward. That's going to have an effect going forward. Are these converging or diverging? We've been talking for 5-10 years about HPC and AI converging. In some ways, yes, and I think that's the popular thing to talk about, the convergence of HPC and AI. I'm really interested in the early market signs around the divergence of HPC and AI. AI needs this, HPC doesn't, right? Where are these things going? AI is driving all of the funding. The processors and systems, the compute side, are where they're diverging first. As we heard about in the Ultra Ethernet Consortium talk that was just before mine, I think when you get into storage and networking, there I think it still is mostly overlapping. There are some differences, but if you're designing storage and networking for large-scale AI, it is mostly going to serve HPC pretty well. And I'm not too worried about your VAS and WEKAs and DDNs and the others I mentioned, not being able to serve HPC because they're too focused on AI. So far, that's in terms of investment. But in terms of, all right, are these pulling apart or carrying forward? And you say, well, that's not really HPC, and it's not. We're going to need these other things. We have heard this before. If I point to these AI systems or low precision systems and we say, well, that's not real HPC, it can't really solve the hard problems, all those flops don't translate into real performance. This is kind of exactly what we heard in the transition to clusters when we had Beowulf clusters coming up in the late 90s and into the 2000s, right? We said, that's not, in fact, IDC, who was the only analyst in town at the time, they separated out what they called capacity computing from capability computing, and, were Beowulf clusters ever really going to dominate the top 500 list? Guess what? They were cheaper, they were industry standard, we went that way. Everyone kind of had to go through the pain of putting their code into MPI, and people hated that, and efficiency went down. Your efficiency scores on all of that didn't matter. Eventually, it all came. I said I wrote this article in HPC Wire a couple months ago. At that time, I had never heard the phrase Ozaki scheme. Then I saw 3 presentations on it within a month. Who here has heard about Ozaki scheme? Ozaki scheme is it's a technique that's come out of Riken, and it's for emulating 64-bit performance on lower precision processors. There are some workloads where it works pretty well. There are some workloads where it doesn't work that well. It's more for math than it is for vector operations. We are doing a series of state-of-the-market reports that's going to include interconnects, networking, storage, data management that'll be based on end-user surveys and inputs from key suppliers, going through surveys with this HPC-AI user organization. Storage and data management is going to be the first up, coming right out of the gate. So we've been doing the budget surveys. Those are now done. We're right now live on the market forecasts. We'll then be publishing the state of the market reports through the summer. And then by the end of the year, we're going to do additional work, mostly on segmenting that hyperscale opportunity into a little more granularity, because that's driving so much of the market. Okay, that's 5 big questions for HPC AI in 2025. Thank you very much. I have 2 minutes left. Do you want me to take a question now or just wait for breaks?
Are there any questions?
That was brave. He base jumping. It didn't even deploy his chute. That was cool.
So I had a question on looking at the cloud, and they're spending so you showed that they're looking at inference engines. Can you take that and say storage for these companies is probably more focused on inference than training for their spending, like projecting?
For hyperscale companies
Yes.
specifically?
Yes.
I'm going to say a quick footnote that I tend to talk about hyperscale companies rather than cloud companies, because I think cloud is a subset of hyperscale. A cloud service is one line of business that a hyperscale company might do. But even among the cloud companies, Amazon is a much bigger company than AWS. Microsoft is much bigger than Azure. Meta isn't a cloud company at all and has one of the biggest hyperscale deployments. Now, your question was, are they focusing more on inference than training? I mean, yeah, it's both, but the inference is the faster growth right now. They've been doing a lot of the training. Inference is the faster growth part of the market. I would say that 2 years ago it was more training than inference. Last year probably went 50-50, and this year it's kind of accelerating into more inference than training. So it's not that one is the whole market, but that is where the growth is. Thank you for the question.
Okay, I think we're up against the break.
There's one more here. Can I take it or not? Sure. We are up against the break, so I just shortened everyone's break. Sorry.
Thank you for the presentation. I wanted to ask you, how will enterprise, do you think that the scale-out hardware that hyperscalers have been developing, is that what is going to drive the enterprise? Will that be adopted in enterprise, or they're going to develop their own hardware, scale-up type of hardware? Traditionally, that's been the conflict.
Will the scale-out hardware deployed by hyperscale drive the enterprise deployment? That's the argument, is that if the suppliers are looking at hyperscale as being the big ocean that they're trying to sell to, that in the long term drives enterprise computing deployment. Now that takes time, just like I said with clusters. And I was talking about things like precision and 64-bit. That doesn't all flip over at once. I think in the near term, there's a market opportunity for companies who are going to focus on the needs of that overlapping HPC AI space where hyperscale pulls away from it. And you're going to have the Gary Gryders of the world saying, well, wait a minute, I'm over here and I have this AI for science need, and you've forgotten the science part. And I still want to do the science part. That, for the next 5 to 10 years, should be a really interesting market. You've got companies like Next Silicon out there. That's not an accelerator, it's a CPU, but they're living in the 64-bit space. I think they'll find a good opportunity to keep doing that in the near term. But in the long term, the big market wins.